Okay, guys, so this is the Hooke's Law setup that you'll be doing for your lab. So what we have here, we're gonna put a spring hanging down. You see it here, and we have this meter stick. So we measure the amount of stretch that goes on with this spring here. So what we're gonna do is put on more weight and watch the amount of stretch that occurs. And we put on more and more weights. And this is Hooke's Law's lab. Again, it's Hooke's Law. Now, if I put on some weight, like you see here, notice that the spring has stretched somewhat. And we know that we have here a state of equilibrium. That is to say, if I ask you what forces are acting on this part of this system here, you say is the spring force going up and the weight going down. Now, spring force going up is K, spring constant time, the amount of stretch that has occurred in the spring. And the weight going down is simply the mass times gravity. That's the weight of it. The mass in kilograms times gravity, that's the weight. It's going down. It's been balanced by the spring force going up. Okay? And Hooke's Law just says in that this spring force is proportional to the amount of stretch that has occurred in this spring here. So you notice that I put on more weight, the spring gets stretched even more. So the more weight you put on, the spring also gets stretched even more. So again, this can be Hooke's Law, and it says in that the force of the spring going up is equal to K, the spring constant, times the amount of stretch that has occurred in our spring system. So we're going to be plotting the weight, which is the same as the force going up, force going down, same thing. So we're going to be plotting the weight, which is the same as the spring force going up, versus the amount of stretch that has occurred. And that plot, slope of that plot, will give us K, the spring constant value. Okay, the spring value. And then this is the first part of that. Now, once we do this part of that, the next part, we're going to take a rubber band. We'll take our spring. Now we can put on this rubber band. And we're going to do the same thing. We're going to take the unstretched length of this rubber band, unstretched length, and then we can put on some weight. And we know the rubber band will get stretched. And we're going to see if this also obeys Hooke's Law. Again, the more weight you put down here, the greater the spring, the greater the force is going to try to pull it back up again. And we're going to do this part twice. We're going to do it first with a unstretched rubber band and put on more and more weight. And then once we've done it one time, we're going to do it a second time. Now that the rubber band have been stretched, we're going to do it a second time with the rubber band that has already been stretched and do the same thing. Let's say we're going to put on more and more weight. And every time we do it, we're going to see how much the rubber band will be stretched, and we're going to compare that and see if it also obeys Hooke's Law. Okay, so again, this part we will do twice. And in both cases, with all three cases, we try to see if the system obeys Hooke's Law.